Randall Walden directs selected study, development, and fielding activities tasked directly by the Undersecretary of Defense for Acquisition. A member of the Senior Executive Service, please welcome to the stage the Director and Program Executive Officer of the United States Air Force Rapid Capabilities Office, Randy Walden.
All right. Well, hopefully the mic's working. Sounds like it is. It's great to be here with you, and I'd love to share a couple of thoughts on what we're doing in the Air Force and in the organization I run. It's also great to see a couple of familiar faces in the audience. Everybody kind of asked, you can go to the first chart. Nice picture of, looks like some Soviet-made, nice jets. So what I'd like to do today is kind of cover some basics of why our office exists, maybe give a little bit of history. We're pushing 20 years now of being around, and then get into just a quick update on some of the weapon systems we're building, some that you would have seen in the press, and then really finalize some thoughts on what we're doing with regard to data and artificial intelligence that's related to battle management and command and control. So the first chart up on history, 3 individuals in the middle. These individuals on about 2000 time frame were frustrated with not only acquisition and the dysfunction that's associated with that, but also the requirements process. And so at that time, the Undersecretary of Defense for Acquisition, Technology, and Logistics, Pete Aldridge, the Secretary of the Air Force at the time, which was Dr. Jim Roche, and then the Chief Staff of the Air Force at the time, General John Jumper, again, said we need to do something about that. And so what they had in mind, it took them about a year or so to kind of come up with what the philosophy was. If you can go back to that chart briefly. What we ended up doing is, instead of recreating a whole new process and rewriting DoD 5000 is, no, go back. Back one chart. No, you're going the wrong way. So there we go. So what we ended up doing is essentially kind of going back to the future. What we ended up doing is looking at successes in the past. And if you look in the lower left, you'll recognize some of the things that are down there. One, Lockheed Skunk Works, a guy by the name of Kelly Johnson, had 15 rules. I think we use about 10 of those. They're very good. Those rules are very good, and they get after reducing bureaucracy and process and getting on with building weapon systems that make sense for the nation. Just below that, I show the National Reconnaissance Office. In the early days, I think it was run by a Air Force colonel, and a very small, I'll say very empowered, and got after what I'll say is our first instantiation of collecting ISR from space. And again, very effective, low bureaucracy, and not process driven. Over the time, I would say the last four decades, roughly, we've created not only policies, but regulations and statutes that get after a very risk-averse way to buy weapon systems. And so fast forward to April 2003, those 3 individuals said, we'd like to do things a little bit different, and we're going to empower you guys to go do it, and we're going to personally oversee what you're doing. So our objectives, I'll go through all 3 of them, but bottom line is literally deliver those capabilities in a manner that meets not only the warfighter, but the national security mission, as well as meeting the combatant commander's needs. And do it in a manner that really kind of gets at expanding the envelope of, I'll say agile acquisition. And so we started off about 2003, and I'll go to the next chart now, get into just some basics on what we've kind of been doing over the last 15 years or so. On the top, I'm not sure if everybody's familiar with it, but we've been operating essentially the X-37B orbital test vehicle for quite some time. We launched Mission 5, or OTV-5, in September 17, and it was on top of Falcon 9, SpaceX's Falcon 9. First time we've done that. We've launched the previous ones on Atlas 5s. Again, kind of pushing the limits of using that particular launch vehicle to make that happen. We landed that after a little over 2 years, 278 days on orbit at Kennedy Space Center, very successful. So a couple of things, takeaways on this is, not only is this vehicle showing that we can go up there do the testing or experimentation and prototyping that we need to buy down risk for very expensive space programs. It's also showing the value with what I'll say is reusable space vehicles. I suspect that as the Space Force, which you probably saw the President sign out on the National Defense Authorization Act, we'll be looking at doing something that's very similar to a reusable space type of a vehicle. And then on the bottom, I show the B-21 Raider. So we've been working on this quite some time, really in the development stages today. Primary thing on this platform is basically to replace the aging bomber fleet. And there's a number out there that are very old. B-52 is the most notable one. B-1 and even the B-2 is pushing a little over 3 decades rather. So this particular platform is to get after any target, hold any target or adversaries at risk, both either from a conventional, which is the majority of what we use it for, to nuclear capability. And we'll replace a number of those bombers I mentioned earlier. It's got a wide variety of weapons that we put on there, again, both from conventional as nuclear. And then finally, we're going to procure at least 100. There's a lot of debate, I'll say in the Pentagon as well as in the press on should it be more. The numbers seem to want to be more. But the bottom line is we're in the middle of producing a bomber today. And I'm looking forward to getting through what I'll say is the development phase and into the flight test phase. Next chart, please. So now let's transition away from what I'll say is building airplanes and space planes and all that into, which is kind of our normal shtick, if you will, but get into what do we do with a lot of data out there. And I'll set the stage this way. Has anybody ever used the internet? Okay, so I'm talking to the right audience there. What's amazing is you go home, you log onto the internet, you don't even think about standards, you just naturally plug and play, download things, and you don't even think about what those standards look like. Yet, when we come to work, and I say the military comes to work, certainly the Air Force, and we log in, other than what I'll say is our normal, Microsoft products and things of that nature that actually touch the internet, when you log into command and control centers, you're kind of going back to the 20th century. And amazingly enough, you ask, well, why is that? Well, we've built systems out there, and we were on that path on the previous two I showed you, where industry will go in with a highly proprietary system on how they move data around, either on the weapon system or to the ground. And a highly proprietary system really excludes connections with everybody out there. And what we found was, we need to kind of break that mindset, break the way we're doing business. And in essence, we pulled in a number of what I'll say is the prime contractors, defense prime contractors, just to have a discussion on what would that look like if you were going to break down that stovepipe, highly proprietary system. And it took them a few months to kind of struggle back and forth because they wanted everybody to go their way. So everybody had their solution and everybody had to follow their solution, which again didn't really help us. In the end, what they came up with, I'll call it a consortium thought, is why don't we kind of do what we're doing on the internet? So again, you're out there would be familiar like XML or HTML type of formatting. The cool part of that is you don't have to invent a lot. You just have to actually come up with what messages do you care about in a militarized fashion, and how would you manage that message format as you're trying to move things around, whether it's coming off a weapon system and going to the ground for a decision maker through a command and control architecture. What would that look like? And of course now, fast forward a few months, we got these standards, a stack of books, and we're proud of the paper. You're thinking, does it work? So we said, we ought to do, let's go build a system, a prototype that allows us to actually play with it. And that's what you see up there now. Common Mission Control Center. If you went out to Beale Air Force Base today, we created this prototyping architecture to literally take what we do in a highly dynamic, highly lethal environment and actually bring in a whole bunch of feeds, bring in a lot of data that has those standards, share that data in a manner that allows us to actually compress, I'll say, the decision timeline. And what we're finding today is the adversaries out there are taking advantage of our lethargic systems in a manner and they're very mobile. And what they try to do is avoid being found, being fixed, targeted, and all that. And so this particular design is to get after compressing that timeline in a manner that allows the national security infrastructure and or a combatant commander to actually get after making that decision that makes sense. Next chart, please. So now, what are we doing with the artificial intelligence? We've been talking about that quite a bit this week, and so I'm just going to kind of at a very top level touch in areas where we're focused. Break it up into 3 broad areas of indications and warning, target custody, and mission planning. In the areas under indications and warning, again, the adversary has been watching us for decades, seeing how our systems work, and looking for areas to do things that surprise us. One way to get after that is start working on something that's really more automatic or autonomous, if you will, and literally pull in a lot of information. Today, if you look at what commercial is doing from space collection, mainly for just mapping out things like Google Map or Waze, just to populate what road infrastructure is out there. A lot of that information done properly, because there's a lot of it, by the use of just basic machine learning or a little bit of artificial intelligence goes a long way to figure out, what is out there, what's useful from what you want to go do. And yesterday at the panel I mentioned, you really need to have a warfighter or a user with you to kind of help you define what that looks like and focus the objective. Once you kind of get that going, you can get into what are the patterns that you see emerging, and then you get into what I'll say is a little bit more proactive versus reactive indications and warning. And if you can get to a state where you can predict what your adversary may do based on just that pattern of life, that military or intelligence pattern of life, it goes a long way. And we're seeing some benefits there. Target custody, once you find it, however you found it, one of the biggest problems is you may lose it. And once you lose it, it's hard to tell if that was the same one or not. So part of that target custody is if I do the left side fairly well and I'm keeping an eye on where things are moving, I can get to a point where I can be very predictive and understand what they're doing, whether it's going out there to do training, is it out there for an operation, is it going back to a depot for maintenance. Those types of things matter greatly in how one would actually try to predict what they're doing from a location point of view. And then finally, there's a lot of military equipment on our side as well as the adversary side that they can only use certain infrastructure, road infrastructure, bridge infrastructure, things of that nature. You get a sense of what would they be doing to be able to predict a better way with a ton of data. And it really does require some artificial intelligence and the algorithms done properly to pull that and glean that information in a manner that helps out the decision makers. And then finally, mission planning. We'll start with the collection deck out there. There's a commercial, and then there's a military intelligence or a national collection. What you really want to kind of do is merge the two. If you merge the two, you kind of get a sense of one, who's collecting what when, call it revisit rates. And in a sense, on the national side, you might be able to do a better job of mission planning based on what you see from commercial. And that's just one metric that would help you in the area of mission planning. And then finally, as you're pulling all this information in, it's been talked about at great length. The lessons learned from just doing a little bit of artificial intelligence with a lot of data, kind of that second wave of AI, gives you, I think, a lot of learning associated with improving processes. So what are we doing in artificial intelligence and data collection and sharing that we enjoy every day when we go home and log on to the internet? What we're really after is trying to compress the decision timeline from a battle management command and control point of view to where you're inside the adversary's OODA loop in a manner where you're going to get your objectives met at your time and choosing as opposed to them. That's really where we're going. All right, that was really short and sweet. I appreciate your time and look forward to doing lunch a little later. Thank you.